Hello, my name is Blake Mattia, and in this presentation, I will be talking about anti-piracy measures and how they're used in computer software. Software piracy is defined as the unauthorized copying, distribution, or use of software without permission from the owner. Now, of course, this can take multiple forms. Like, for example, you may find Microsoft Word uploaded online to some sort of illegal website and where you can freely download Microsoft Word without having to pay for it. And because of situations like these, several companies try to find measures to prevent people from doing this. The first system I will go over is digital rights management, also known as DRM. This system enforces licensing checks during runtime and not just at the start of the software. And these checks are done by either accessing some sort of locally encrypted license file or by checking a remote authentication server. One of the big examples of DRM is de novo anti-tamper, which is used on several different video games. And License checks are done by encrypting parts of the game's executable file and only decrypting them during execution of the game. The next system I will talk about is software activation. This system is where whenever you want to use or purchase a software, you have to enter an activation key in order to use it. Uh, and then whenever you use these keys, it is sent to an authentication server where it checks to see if the key has been used before activating your software. And then whenever you use these keys, it'll deactivate its usage, preventing you from sharing the key so that you can't just give everyone access to the software. And this system is safe because it prevents large scale key sharing. Like, for example, the Windows operating system, the activation servers will track how many times their keys are used to see if the same key is used far too many times than a normal person would use it in order to prevent its use. Uh, and then also some software will use hardware embedded keys, uh, which adds more protection to the software. The next system I will be talking about is software as a service, or SaaS. This is where the software shifts from being executed by the client to a server-side execution. Meaning that instead of distributing the full application, the developers of the software will host it on secure servers where users will interact with the software using a web interface or API. And then authentication for the usage of this software is typically handled using some form of secure protocol or session-based authentication system. SaaS is highly resistant to piracy because the actual server software never leaves the server. Like, for example, Google Docs, you can't really just download the software, as the only way to use it is through the cloud. And then for other software that's not free, uh, you could easily just share a login. However, through this method, companies can like track uh, unusual activity, like logins from multiple different locations, in order to restrict access. And then, even if somebody were to find some sort of vulnerability in order to try and pirate the software, they only need to be patched through the server instead of having to rely on the fact that everyone is updating the software. The next system is code obfuscation, which involves transforming a program's source code into a form that is extremely difficult for potential pirates to try and understand. This can include like renaming variables to meaningless symbols or inserting redundant instructions that will throw them off. And then sometimes, in some compiled languages, developers may use packers or encrypt sections of the binary that will only be decrypted at the runtime of the software. Software that uses this method uh, increase the complexity it takes to reverse engineer and pirate the software. Like, for example, or one of the biggest examples of this are like Java applications will use a tool called ProGuard. And this ProGuard removes debug information and renames all the classes and methods to complete gibberish. And it must be known, though, that obfuscation, its main goal is not necessarily to prevent piracy, but instead to just to make it take a lot more time and expertise from the pirates in order to try and distribute it. The final system I will be talking about is hardware-based protection, which is where physical devices will be used to store a cryptographic key, and then the software that you are trying to use will communicate through this hardware device through some form of secure API in order to verify that the correct key is present before it executes. These devices could be a USB dongle or some other device that has integrated security modules. And this approach can be effective if the cryptographic keys are stored in a tamper-resistant hardware. Uh, one of many examples that I found were from enterprise applications, where the enterprise would use a USB dongle that if you tried to tamper with it, it would stop working and you wouldn't be able to use it again to activate the software. And then since the key never exists in software form, it can be extremely difficult to extract it and or duplicate it for others to use. As people trying to pirate the software would not only need to get the key, but they would also need to physically replicate the hardware, which takes significantly more effort than just cracking it through software. It must be known, though, that none of these systems are completely effective at preventing piracy. And piracy is always just an ongoing battle between developers and pirates trying to crack their software. And that the main goal of developers is not necessarily to eliminate piracy, but instead to make it just a lot more convenient for users to just choose a legal option, as it may take way too long or maybe way too difficult to try and obtain it illegally. Then, even for legitimate users, their experience with the software can be negatively impacted by the use of some of these systems. Like, for example, with DRM and Denuvo, if you're playing a single player game, you still need an online connection to boot up the game and continue to run it. Uh, and then along with that, a hardware system It can be inconvenient as you have to keep track of the physical device, and if you lose it, then you do not have access to that software anymore. And then, as for the future of anti piracy, as I said, it's always evolving in order to try and stay ahead. Some companies are looking into using both AI detection and blockchain licensing in order to authenticate its users. Uh, on the other hand, there's also a big trend towards a lot of software being cloud based using the SaaS model instead of being physical software you download. To conclude, software piracy is a very complex and ongoing issue for developers, with companies often using several of these different mechanisms in order to maximize their protection. However, they're still having to balance uh, the experience for the legitimate users.